Hello, it's time for another SBUS mixer demo, and in this one we're going to take a look at how you can get a sequencer kind of behavior. There's no specific node for sequencing, but there's two nodes that work together, the Slew node and the mapping node, and they can give you the same kind of result. And this video will be quite quick if I just showed you the physical demo here and then said thanks for watching, bye. So I will also show you the program side of it and how this was set up. So what we have here is SBUS mixer in the middle of a huge mess of wires. I think I have 9 servo outputs and just one digital output for this LED there. And the input is just the iBus coming from the receiver, and the radio is the FlySky radio, and there's a big battery over there powering everything. So the first thing we're going to look at is the Slew node separately without any of the sequencing or mapping. So Slew just means that instead of immediately going to the position where the switch is, I have a 3-position switch on this servo, and if I switch it to the middle position here, it doesn't go there immediately, it goes there over a period of time, and so this could be used for like flaps or something. So this would be now full flaps, and the Slew node can go faster in one direction than the other if you want. So if I go all the way back to the beginning now, it's going to go faster than it did in the forward direction. So that's just Slew by itself. So let's have a look at the program side of that.
Okay, so this is the whole program that's running on the SBUS mixer in this this demo. Man, I wish it was a better name than SBUS mixer. I'm getting sick of saying it. We'll look at the bits down the bottom later on. For now, we just want to look at the very simple section at the top. So we have a input. This is a serial input, and in this case it's iBus, but could be SBUS as well. And whether it's iBus or SBUS and which UART port it's on is decided in another section of the settings. So this is not supposed to be a tutorial. I'm just padding out the video a bit and giving you a look at some of the way that this stuff works. And I'm just kind of soliciting questions and comments, really. I just want to see what people think at this point, even though it's not explained properly. Anyway, so iBus, channel 5 is coming in, and on the output side we have servo PWM output on pin 9. And in the middle we have this Slew thing that I was mentioning, and in the forward direction that's going to take 6 seconds to travel the full span of the low to high, and in the other direction it's going to take 3 seconds. So that's all we were looking at there. Pretty simple. Now, given that this Slew changes over time, we can make use of that in conjunction with a node called mapping, and mapping is one of these, and we can set up some points in here graphically by just dragging them around and putting some points in there like this, and it will take the input along the horizontal and give you whatever output you've decided it should be in the vertical. And again, I'm not going to explain a whole lot about it, but suffice to say that we've got this set up here, which we'll look at in just a second, and these mapping nodes have like a sub editor where we can set up a sequence for each of them. And we'll notice here that they basically have the same thing, but it's just shifted over a little bit in time. And this time we're on channel 7, so that's another one of the switches on my radio. The Slew in the ascending order, or the forward direction, is going to be 2.5 seconds, and then descending it's going to be 8 seconds. And it's again going out to 4 servo outputs.
Okay, so let's see the mapping in action with these 4 servos here. And we have 4 servos with a little bit of foam board stuck to them, and then a little piece of paper stuck to the foam board with a number on it. And since I've already explained how this is going to work, we'll just run it. So that was just this 2-position switch now. And when I go back the other way, as we saw, this should go slower in this direction. There we go, and it should be safe to switch backwards and forwards at any point. Oh, of course it's going to go slower in the reverse. So it should be fine to do that, I think, yeah. Of course I checked before making the video, I'm just pretending. Anyway, that's fun, isn't it? So the next thing we're going to look at is a landing gear door simulation. So we have two servos. Well, you can't really see the other one there, but there's a servo over there and a servo here. And then we have two of these landing gear retract things. These are actually for multi-rotors, so they only go to 60 degrees instead of 90 degrees, but just pretend that they go to 90 degrees. Let's just have a look at the program before we run that.
Okay, so now we are looking at this section here. And as before, we start off with a serial RC input, and that's a switch on the radio again. And that's going into a couple of things here. One is a digital output to control the landing light, and that's where the end of that chain goes. That's pretty simple. And then another slew. This time it's going to be changing from 0 to 1 or across the full scale over 10 seconds. And that's going into 3 mappings. And we have 4 servos though. So the first mapping is actually going out to both of the doors. If you have a Y cable, you might be able to just have one servo output, but I wanted to have 2 servo outputs because I found that I needed to change the endpoints here. You can see that the one servo, excuse me, I'm only letting that go down to 1150, and the other one I'm only letting that go up to 1920. So that was a reason to have 2 servo outputs there. Plus I didn't have a Y cable sitting around handy anyway, so I might as well just use another servo output. Anyway, the mapping, or the sequence, if you like, that's going to be performing is the door, or the doors, both of them, will open, and then they'll wait for a while, and then they'll close. And we have a couple more mappings down here for the struts, or I'm calling them the struts, but the actual landing gear itself. And they are not servos, right? They are the retract thingies. So they function just high and low for their inputs. That's all they take. And they have to wait until the door is open. So I'm thinking maybe to make a way to line these up so that you can edit them the same, like you can see it a little bit better how they match up, because these 2 sequences have to be functioning together. You can type numbers in directly to get what you want, or just move things around like this is often good enough. But anyway, so the door will open like that, and then this green line is the forward direction. You can see that we actually have an asymmetrical sequence now, or asymmetrical mapping. So the green is the forward direction, and oops, go away. So it's going to be, it's waiting for the door to open, then it's going to bring the strut out, and then basically just stays low the whole rest of the time. But on the way back in, it can't bring the strut back in all the way back here, because the door will be open at that point, but the door will be starting to close, and we don't really want that. So we need to bring the strut in a little bit earlier here. So this time we're coming from the right and we're going towards the left. Hope that makes sense. So anyway, on the blue line is what we're going to get on the reverse direction. So we could have done both of these struts the same with the same mapping, but I wanted to show how you could make it a little bit more customizable. So in the second sequence here, or the right strut, we'll see that the green direction, or the forward direction, is the same, but when the landing gear is being pulled back up into the plane, it's going to be a little bit quicker on this one than it is on that one. And this is just to simulate the way you see on some warbirds. Unfortunately, I can't remember which one it was. Maybe BF 109 or something, Spitfire, something like that. Typically the landing gear comes up kind of one at a time. They don't really do both the gear doesn't come up at the same time. Anyway, let's look at that.
Okay, so let me flick the switch. I'll just move back a bit so you can see that the light is also going here. Like that, and you can actually see in the background that the landing light is still on. Now we're retracting, and they come up at different times, as you saw. Hopefully I pointed that out in the GUI side of it. Just run that again. And I should be okay to just switch this off and on at any point too. Yeah. think that's okay to do that. I'm not so sure with this one. I've done it a bit and it hasn't given me any trouble yet. Okay, so that's about it. And there is also a little bit of extra stuff going on here. We have a little screen display showing some information that's being pulled from the GPS there. But since we're inside, we don't have any satellites, and it says hour, minute, second, so normally that would be showing you the GMT time, but since there's no satellites, all it's showing you is how long it was, how long ago I turned the system on, so like 7 or 8 minutes ago. The number at the bottom is correct though, 10 Hertz. This is the actual number of messages that it received per second. It's measuring that. So we expect to see 10 or occasionally, yeah, it's not actually 11, but 9, 10 or 11 is usually what it shows there. But that's not really part of this demo. I just wanted to put that there to make the point that this system can do a whole lot of other stuff all at the same time without even really working too hard to do it. Now we're at the end of the video. Thanks for watching. Bye.